Okay, welcome back to Maths Year 12, and today we are going to start our first lesson on Chapter 2 called the modulus function. So this is Lesson 1. Okay, the modulus function. The modulus of a number is written with these two lines here. Okay, and what it means is it means you just take the positive value of the number. So, for example, the modulus of -3 just means 3. And the modulus of 3 just means 3. i.e. the modulus of -10 just means 10. The modulus of +10 just means 10. We're just taking the positive value. Now, what we're going to look at next is how we sketch graphs that include the modulus sign. So we're looking at how we sketch the modulus of x in this case. Now let's first of all look at the line y equals x. Now a sketch, we don't have to be exact, so we're just going to draw some axes, x and y axes. I'm not going to put the scale on here. Okay, now y equals x, we're going to do it with a dotted line for the moment. Okay? So, and I'll explain this in a moment. So y equals x is this line here. Now, let's think about what happens when y equals the modulus of x. So, if y equals now the modulus of x, that means that y takes the positive value of all the x values. Now, this part of the graph, all of the y values are positive. In fact, all the x values are also positive. So this must belong to my line y equals modulus of x. Let's look at what happens when the y values are negative. For example, let's look at what happens when, for example, x is, say, -2. Okay? So y equals the modulus of -2, which we know is 2. Now, on this line here, y equals x line, obviously the x and the y values are the same. But y equals modulus of -2 will just be +2. So this point here will go up to here. Let's try another one. Let's say, look at negative, say 10. So when x is -10, y will be -10. But when we look at the modulus of -10, we get +10. So this point here on the line will reflect to up here. So what happens to all of these points is they will become positive. So they reflect, what's happening is they reflect about the line y equals, about the x-axis. So let's just recap that. All of my positive values for y, i.e. everything above the x-axis, will stay the same. And everything beneath the x-axis will reflect about the line, the x-axis line, the line y equals 0. Okay, let's try another example of that. Let's look at sketching this graph here. So step 1, I'm going to sketch y equals 4x minus 1. Now, to sketch the graph, I need to look at where it crosses the x and the y axis. So I look at my values when x is nothing and when y is nothing. So if x is nothing, y will equal -1. When y is nothing, I will have this. So x will equal 1/4, just rearranging it. So when x is nothing, so this will be -1 here. When x is nothing, y is -1, so that will be there. And when y is nothing, x will be 1/4, so that will be there. Now I'm just going to draw this line with a dotted line for the moment. Okay, so that's my line, y equals 4x minus 1. Now, if I put a modulus sign in now, y equals the modulus of 4x minus 1, this means that y cannot be negative. I cannot have any negative values for y. So, all my positive values of y, i.e. everything above the x-axis, so y goes from 0 upwards, all my positive values of y will stay exactly the same, i.e. when 4x minus 1 is positive. Beneath here, my 4x minus 1, they are all negative. Yeah, everything beneath here, you can see that y is negative. And what happens is that line will reflect about the x-axis. So my end answer is I get this V shape, okay, for y equals modulus of 4x minus 1. Okay, so I'm going to give you one to try now. I'd like you to try this one. Just pause the video and try sketching that one, and then I'll go through the method. Okay, let's see how you got on with that. So step 1, we just plot the line. Okay. Now to get the line, you need to look at when x is 0 and when y is 0. So when x is 0, I get y to be 5. When y is 0, make this equal to 0, I'll have x is negative 5 over 2. So when x is 0, y is 5. Let's put that there. When y is 0, x is negative 5 over 2. Okay, I'm going to draw this with a dotted line. Okay, you can draw it with a ruler if you want to. Okay, I can see this has got a positive gradient and this has got a positive gradient. Now I decide which part of the line flips. Right, everything above the x-axis, my y values are positive there, so they will stay the same, and all my negative y values will flip to make them positive because I'm doing the modulus of it. Okay, so this V shape here is y equals modulus of 2x plus 5. So the whole of this V shape. So I hope you've got that now. And if not, try some more from the book and check your answers in the back of the book. Right, next part. Now we're going to look at solving equations with a modulus sign. So if I was to solve 3x minus 2, the modulus of that equals 4. Let's see what happens on a graph. Okay. So let's plot y equals 3x minus 2. First of all, let's think about this graph here. So when x is 0, y is minus 2. And when y is 0, x will equal 2/3. So I would get, this is my line. Everything above the x-axis is positive and everything beneath is flipped. So I get that as my modulus function. Okay. Now I want to know, when does this equal 4? And I can see that this goes through plus 2 because that negative 2 will go to plus 2. So when will this line equal 2? Well, sorry, equal 4. So if I put this here, so this is the line y equals 4, I can see that where my modulus function intercepts my line y equals 4, I have my two answers. So there are two solutions to this, the two intersections of y equals 4 and y equals 3x minus 2. Now, how can I work out what those intersections are? Right, well, this part of the graph, if I'm looking at point A, okay, so to find point A, the x value there, this was my positive part of 3x minus 2. Okay, so that stays the same because it's all positive. Equals 4. So if I solve that, 3x equals 6, so x is equal 2. And that makes sense, doesn't it? Because that's 2/3 and that's 2, it's positive. So my one solution is x equals 2. Let's look at point B now. Right, well point B is this 3x minus 2 is flipped, yeah? So this is y equals 3x minus 2, but this is y equals minus 3x minus 2. So I'm actually solving, put the negative sign outside, the negativeness equals 4, because this line is negative 3x minus 2. So if I just get rid of that negative sign, minus 3x equals 2, so x will equal minus 2/3. And that again makes sense. We can see here that x is negative. Okay, so I've got two solutions. So I have to sketch the graph first to make sure how many solutions there are. Sometimes there won't always be two solutions. Sometimes okay. Point A, I make the positive part of the graph equal 4, and point B, I make the negativeness equal 4. Right, so let's look at another example. Now, you might want to try this, but there is a little catch into this one, so you might want me to wait for me to go through this. Up to you. You either pause and have a go, or wait for me to go through this. Okay, so let's have a look what happens here. Right, so let's first of all sketch. Okay, so I'm going to sketch y equals 4x plus 3. So it will go through 3. When x is nothing, I'll have minus 3/4. Sorry, when y is nothing, minus 3/4. I'm going to make this dotted. Okay, now everything above will be positive, everything below will be reflected. So now I've sketched y equals the modulus. Right, okay, so I've got now a line, okay, so y equals, I need to sketch this line here, so let's look at this. No modulus involved. So when x is nothing, I have 2, so it goes through 2. When y is nothing, I will have x is equal to 2 as well. Okay, so I'll have that. And then if I draw it with a different colour, this will be the line. Okay? Right, so that's this line here, the purple. Right, now I've definitely got one point of intersection, A. Do these two lines, is the next question, do they intersect? It's difficult to tell from the graph. So let's think about the gradients of both of these lines. If the gradients are the same, then they're parallel and they won't intersect. Well, the gradient of this line, y equals, if we compare that to y equals mx plus c, we can see the gradient of this line, the pink line, is -1. Right, the gradient of 4x plus 3, that gradient will be 4, yeah? And so therefore this gradient will be -4, yeah? So the gradient of this line is -4. So this line is steeper than this line. So eventually, yes, they will intersect, because obviously -4 is steeper than -1. I haven't quite drawn it. Obviously your sketches might not be drawn correct. If this gradient was less than -1, okay, then they will diverge and they won't intersect. Or if it was -1, again, they will not intersect. So you have to look at the gradients. So the gradient of this line is steeper than the gradient of this line, so they will intersect. If it was not as steep, they wouldn't intersect. So to find my points of intersection, let's look at point A. So point A, I have my positive part of the modulus, because this is the positive part, this is not reflected, equals minus x plus 2. So if I just rearrange this, 5x will equal negative 1, so x equals negative 1/5, which, yeah, makes sense. Yeah, just check that, and 1/5 is smaller than negative 3/4, that makes sense. Right, where these two intersect, let's call that point B. So I've got the negative part of the graph now, the negative part of the modulus, equals my line. This doesn't change sign because here there's no modulus. Okay, so let's solve this. Let's multiply by the negative sign. Let's take all the x's to this side, all the numbers to this side. So I have 3x, so x is negative 5/3, which makes sense, doesn't it? It's over here somewhere, negative 5/3, if I extend that line. So that's point B. So I've got two solutions here. Okay, well done, good listening. It's a bit of a long video, this one. Right, next. I've got, I think, 2 questions left to go with you. Yeah, probably another 5 to 10 minutes. Okay, now we're going to look at solving an inequality. Okay, so again, we're going to sketch it, and then we're going to look at the sketching. So let's just do a nice big graph. Okay, obviously you have to sketch your graphs. So y equals 2x plus 5. So when x is 0, y is 5. And when y is 0, x will equal negative 5 over 2. So let's just dot it to begin with. This part will be positive, that will stay where it is, all my y's are positive, and this part will reflect to get the modulus. Okay, now I'm going to sketch this line here. So I'm going to now look at y equals minus 2x plus 2. So when x is nothing, y is 2. And when y is nothing, I can see that x will equal plus 1. Okay, so here. Yep. And if I draw that in a different colour, I have that line. Okay, so this is my line, y equals minus 2x plus 2. It's good to have different colours for your 2 different lines. Okay, straight line, just use a ruler, unlike me here. Right, so now we want to ask ourselves, where is this modulus less than this line? Yeah? Now, is this going to intersect, I wonder? They look a bit parallel to me. Let's just see. So we've got this line here. The gradient of this line is negative 2. The gradient of this is positive 2. So the gradient of this line is also negative 2. So these 2 lines are in fact parallel. So these 2 lines will not intersect. So we've only got one point of intersection, A. So we want to ask ourselves, when is the blue graph beneath the pink graph? Well, the blue graph is beneath the pink graph here, and in fact, all the way, this will carry on, yeah? The blue graph for values of x is always beneath the pink graph. This section of the blue graph is always above the pink graph. So this is my blue graph. When is my blue graph beneath my pink graph? So I just need to find this point A. So to find point A, I know that the positive modulus is equal to my line. So 4x is negative 3, so x is negative 3/4. So x is negative 3/4 here. So my answer will be an inequality. So all my values of x less than negative 3/4, all my values of x less than negative 3/4 will be my solution for when the blue graph is less than the pink graph. If it equals negative 3/4, then they're the same, so it can't equal here. Right, time for you to have a go at doing one now. Try this one, okay? If you think you're happy with that, just scroll on and get the answer, and then you can go on to the work today. So one last question. Let's look at this one. Okay, let's sketch my x and y axis. So let's look at sketching y equals 3x minus 4. So when x is nothing, I have negative 4. When y is nothing, I will have 4 over 3. Just to check that, make sure you're happy with that. So I'll have 4 equals 3x. So you can see x is 4 over 3. Okay, so I'm just going to do my dotted line. I know everything above the x-axis will stay the same, and everything beneath the x-axis will reflect. So this is my line, y equals the modulus. Right, let's draw my line y equals 2x now. I'll do that in a different colour. So it will go through 0, 0. It'll have a gradient of 2. So this is a gradient of 3. Yeah, and this is a gradient of 2, so it will be not as steep. So we do have 2 points of intersection A and B. Right, so we need to find those 2 points of intersection, and we want, when is the blue graph above the pink line? So let me look at that. When is the blue? Blue is above the pink there, and blue is above the pink there. So if I can find my two values of A and B for x, I can then write my inequality. So point A will be, well, this is the negative part of the modulus, will equal 2x. So let's work that out. So 4 equals 5x, so x is 4/5. Yeah, that makes sense. 4/5 here. And this answer should be more than 4/3. Let's just check. So point B, my positive part of the modulus will equal 2x. So 1x equals 4. Yeah, that makes sense. So my answer for this inequality is I want all these x values, yeah? So I want x is bigger than 4, can't equal 4 because they're the same, and I want all of these x values here. So I want x is less than 4/5. So this is my solution. Right, good listening. That was quite a long video, quite a lot to get through there. So take your time, have a go. I want you to do these questions, please. Do nice big sketches, not tiny sketches, nice big sketches, clearly showing your method. Thank you, have a good day.